everybody, and welcome to the 35th edition of the community call. My name is Rob. I'm an engineer from the documentation team here at Hasura, and we're very happy to have all of you here today. I'm going to go ahead and jump to our agenda, and as you can see, we have a packed schedule today with a lot of exciting things that are coming down the pipeline. And without kind of, dancing around it, we're just going to go ahead and dive right in with something really exciting. And we have somebody who I know a lot of people have been dying to see on this call for a little while. I'm going to go ahead and bring Tanmay up on the stage right now. Tanmay, how are you?
Good. Hey, Rob.
Hey, I'm going to stop presenting my screen, and you're going to talk to us a little bit about deploying some custom code on Hasura, which I know is going to get a lot of people very excited.
Cool. All right. So this is something we've been working on over the last few weeks. We haven't released it officially yet, but just wanted to share the preview launch with you folks, and you folks can start trying it out. The docs pages and everything is up. And so I'll kind of walk you through the use case and how you can start trying it out and start building and deploying stuff pretty quickly. So Hasura Connector Create. This is the new CLI capability that you'll see. There's a new connector plugin that we've released, and the connector plugin essentially allows you to create and deploy custom code to Hasura for all sorts of fun use cases. So typically, if we think about kind of the use cases that we've been seeing, where people need and want to deploy custom code with and alongside Hasura, it kind of spans a bunch of different use cases, right? So we have this kind of, the most common use case, of course, is if you're building a backend, a GraphQL backend or an API backend, you often want to have event triggers or actions and other things that can deploy business logic. We'll talk a little bit about, for example, input validation and stuff that we'll see. When you, so typically the kinds of use cases that we see are, you want to have like event triggers or actions and business logic functions that you want to deploy, right? We'll talk about input validation a little bit later, right? And that's the kind of stuff that you often want to deploy alongside Hasura too, right? Then there's often generic functionality that you want to bring in, right? This could be, for example, authentication services or file storage services that you kind of want to plug into Hasura as well. Two data-related use cases that kind of span not just kind of bringing in these custom services or custom databases, but also very kind of advanced but obvious use cases that you also might encounter. There's often these use cases that you'd see with hot and cold storage, right? Where you're like, hey, I want to have like time series data that I'm querying, and if it's less than 90 days, I want to go hit this database, and if it's greater than 90 days, I want to go hit that database, right? Or use cases where you have, weird compliance requirements, for example, where you have 3 different types of databases and 3 different databases, the same schema, maybe it's in the same type, but you're hitting one query and you need to union results from these 3 different types of databases, right? And so in these kinds of situations where it might not be all of your database, it might be some tables within the database where you want some custom behavior, and this kind of stuff that you often need to do, it becomes useful to be able to kind of customize the way Hasura is planning and the way Hasura is kind of doing its data fetching, right? And so over the last year, as we've been kind of building out support for custom connectors, we're now kind of adding to that capability of saying you can start deploying custom connectors as well. So deploying that custom connector is on Hasura Cloud is as simple as just saying Hasura Connector Create, giving it a name and pointing it to a GitHub repository. You can have a bunch of different ways to kind of deploy from your GitHub repository, whether it's on the main branch or whether it's a particular commit, and you can kind of point to that tag or commit or to the main branch and then just kind of deploy that GitHub repository. Hasura will pick it up, build it, and deploy it to cloud. You'll get an HTTP endpoint, and now you can take that HTTP endpoint and use it wherever you can add to your console or metadata. So this is what you can start trying out on, and you can see the docs link here so that you can start playing around with it. I'm going to talk a little bit about the advanced use cases around connectors, and then I'm going to ask you folks for a little bit of help, which we'll talk about in a second. So at a high level, the way that we think about the world is that it's one kind of giant database, right? It's composed of a bunch of collections of things like tables and relations and things that are essentially models that you can do CRUD operations on, or a variety of CRUD operations on, right? You can paginate and stream and fetch them, or you can write to them and mutate them and delete them, right? And then there are these procedures, which are like transactions that operate on these collections, right? That's what everything is. Any API is essentially that's what it has, right? A database also has all of these things. So that's kind of on one side, right? And that's kind of if you think about that generic abstraction, that's what you want to bring in. On the second side, it's like, but if you try to do that, and if you think about the way Hasura is architected and why it has so much performance on Postgres, the core idea in the way that Hasura operates is that, N+1 queries are terrible. Data loader is not optimized for modern databases. And Hasura does a style of query compilation and planning that can take kind of different routes for fetching data. That is something that we want to leverage, right? So we want to kind of have that genericness of saying, well, the whole world is a database, and we want to build high performance data fetching logic to be able to get data from wherever it is in the world, right? And while Hasura does this for the databases that we support, that we will support for, right? What becomes challenging in the kind of use cases that we were talking about earlier is that, what if it's a custom type of data fetching logic, or what if it's this amazing new database that you want to use, right? And so these are my top list of databases that I'm looking on. ClickHouse, which is something that Benoit from our team just built that you can start playing around with. Tiger Beetle, which is this cool database that I came across, somebody pointed me to in the team, which is financial transactions database. It's a fixed schema, but it lets you do millions of transactions at distributed scale per second. And then, of course, there's MotherDuck. I'm not sure how many of you folks have come across DuckDB, which is like a SQLite OLAP, but cloud version of that, right? And so if you want to try out these amazing new databases and integrate that with your system, and you know that there's a bunch of use cases you can fulfill with these databases, it'd be amazing to do it, right? But say Hasura doesn't have support for it, right? So how do you kind of get that Hasura style GraphQL API, the Hasura kind of query compilation performance, and add support, incremental support for these bits, right? So then I want to introduce you to NDC Hub. We talked a little bit about this at HasuraCon, but you can check this out at github.com/Hasura/NDC Hub, which has an initial SDK that's in Rust, but we'll be adding SDKs in a bunch of different languages. So you can head to NDC Hub, and we'll send you links on email later, but you can essentially build out extremely custom connectors with custom query planning logic fairly easily, and connect that to Hasura. And then, of course, if you're deploying that to Hasura Cloud, you can just use Hasura Connector Create that I talked about. And if you're running it yourself, then you can just run it wherever you can run that process or that function or that Docker image, and then take the HTTP endpoint and connect that to your self-hosted Hasura instance. But this hub has the SDK and links to the reference documentation so that you can kind of build out these complicated query compilation style connectors easily, and you can kind of bring whatever whatever kind of database or whatever kind of SaaS API, and you can start connecting that to Hasura. While this is all still in alpha, and is like pre-launch and pre-preview for everybody, what we wanted to get started with some of you folks here is to get your input on what languages and what language SDKs you want. We have Rust now. We're planning to do TypeScript, and then we have Python and Go as well. But what kind of SDKs do you want to see, that you want to start building stuff with? What kind of data sources and SaaS APIs do you want to build, or do you want to see support for? If you head to the repo there, I've created a bunch of issues so that we can start kind of getting your input in. And as you play around with it, your feedback is going to be critical as we move towards a beta in a few weeks. But this is ready to try out, and is ready to build. And we'll be sharing a bunch of examples with ClickHouse and Postgres in this kind of style, so that you can start customizing it, using it, playing around with it, and building on top of this. So that's me. That's my time. I'm going to hand it off next, folks. Building on top of the connector create stuff, we have a bunch of really cool things on the Python and AI side of things. And then, with that ability to also create custom connectors, we'll hear a bit about authorization and input validation type stuff. Also, that's going to be coming up. So super excited for all of the stuff that's coming up now.
This is awesome, Tanmay. Thank you so much. After all the work that we've done recently on our generative AI course on Hasura Learn, it's really cool to see these custom connectors being able to be deployed. So this is a nice way of things coming together. Really exciting. Next up from our evangelism side of things in the dev education team, we have Akash joining us to talk about Authz performance enhancements. We're going to be looking at Hasura and kind of be thinking about row level security in Postgres versus how it is in Hasura, and find out some cool things today. So let me find Akash in my list here. Akash, how are you?
I'm good, Rob. Hi, how are you?
Hey, doing well, doing well. I'm going to go ahead and turn it over to you. I'm going to hop off the stage if you want to share screen and dive into it, all right?
Sure.
All right, thank you.
My name is Akash. I work as a technical evangelist at Hasura. And the topics that I want to cover in this session are the recent query plan optimization that we did for some common permissions use cases, and then compare the Hasura authorization engine performance against Postgres low-level security. While we are doing this exercise, we also want to make some observations on the complexity or intuitiveness of both paradigms. And finally, we will cover the complex use cases where Hasura authorization allows you to have remote relationships and enable complex query plans on not just Postgres, but other DBs as well. For our purpose, let's go ahead and choose this Chinook database. And over here, we can see the database schema for the Chinook database. For this session, we are concerned only with the artist, album, and the track table. Let me go into slideshow mode. Sorry. Yeah. So the use case here is that there is a certain user or artist who logs into the system with the artist ID set as a session variable, and he should only be allowed to fetch tracks where they own the album. So a certain user or artist should not be able to get access to tracks which do not belong to him or her. This is a very common use case where the child is accessible based on the property of the parent, the child here being the track, and it's related to album via album ID foreign key. And album is where the artist ID resides, which makes this decision of whether the track should be returned as a result for a certain user or artist or not. Okay, so let's do a quick revision of how we would set up the permissions for the album table in Hasura. So we would go ahead and add a user and give him or her access on rows with a custom check where the artist ID equals a certain header. So I've named that header as accessor artist ID. And similarly, we will do the same setup for track table where the user has access to rows where the album's artist ID equals the header's value. Now, once we have configured these permissions, we can make our query and see it working. So here I have just captured a screenshot of a query and the results. You do have to provide the necessary headers. So the accessor artist ID chosen a random user ID over here, 1610, and the role for which we have set up the permissions, and this query works. If we analyze this query, we can look at the generated SQL. So let's pay attention to the left outer join which is happening here. So the album table gets left outer joined to the artist table, and this clause where the artist ID comparison to the header value is happening, it's also happening in the child entity. So which, if we reason it out, seems to be redundant, because in a left outer join you would only get the matched rows from the right table, the right side table, right? So performing artist ID check on this side is redundant. So we reason this out, and we okay. So before I discuss further about it, let's just look at the query plan, the planning time and execution time. The result comes up in 0.351 millisecond. And this is how the visualization of the query plan looks like. Yeah. Coming back to what I was pointing out as the redundancy. So we have this new feature, optimize permission filters, where we realize that when the role level permissions are applied by translation into the where clauses in the SQL statement, and if the joins are happening and the query is complex enough, then the generated SQL may have redundant where clauses, which are essentially doing the same thing. So we built an optimization to remove such redundant where clauses, and you could try out this feature by setting the Hasura GraphQL experimental features in the Docker Compose. In case you're using Docker Compose or whichever way you are using, you can enable this environment variable and this feature will be available. Okay, so now let's compare the generated SQL. This was the earlier SQL which we are looking at, and this is now the generated SQL post enabling the optimize permission filters environment variable. As you can see, the clause from in the track table where it was filtering on the artist ID, that has just disappeared. And if you look at the query plan, the execution time has improved from 0.351 millisecond to 0.311 millisecond. So this was the new performance enhancement that we have. Let me introduce PostgreSQL row-level security here. So row-level security is an important feature in PostgreSQL security context. It allows database administrators to define a policy on a table such that they can control what a user can view or manipulate. So it's an additional filter. It's more like a security filter where a user should not be able to do or should not be able to query or manipulate some data which he does not have access to. So we did a fun experiment where we just thought that what if we take our authorization engine and the generated SQL which we obtain from it and set up the similar data set on Postgres and compare the performance of both of these queries. And to our pleasant surprise, we saw that the query plan that Postgres, RLS-enabled Postgres came up with was much slower and costly to what Hasura is doing. So as you can see here, this is the same query. It takes 501 millisecond to execute, whereas the query using Hasura's authorization engine was taking just 0.351 or 0.1311, depending on whether you have enabled the optimized permission filter or not. We have open sourced this experiment, so you can find that here. And we kind of concluded that our execution time is much better than what RLS-enabled Postgres is providing. We took this as an opportunity to learn something as well as communicate to PostgreSQL team. So we connected with them on the mailing list. We are yet to obtain an official reply, but from our side, we went through older mails where other users have pointed out similar problems, and this is what their reply is, that the join cases with RLS aren't optimized very well at the moment, and there's work afoot to improve this. So please do note that this mail is from 2016, and this work has not landed yet into Postgres. So the query plan that I was showing earlier, this is on the latest version of Postgres. So what makes it difficult for Postgres to improve here is that they have this model where security or the security level filter and the query level filter, they cannot interact. So they are not able to perform better or identify whether an index scan should be performed in a certain query plan or a sequential scan should be performed. So they have this isolation levels. Okay. Moving on to the other aspect of Hasura authorization, where the generalizability part of it, where it's not just Postgres on which we perform authorization. We enable authorization on a number of database systems, and you can easily enable complex query plans. So over here, there's an example of a complex query plan which we had come up with. So there's an HR application where the hiring manager application ID info sits in Postgres, and the resumes, the documents, they can be in a vector DB or an object store. The query that a hiring manager wants to make is that he wants to get the resumes, but he should be only able to get the resumes for the roles which he or she is hiring. So we can define this relationship between two database systems, and then we can configure the necessary permission for the user. So this is the permission. Hasura provides authorization over popular databases. You would have seen these on our console, and over here there are a lot of database systems. There are some variations of PG, Postgres, which may or may not have RLS. And it's not just that we support these databases. You could bring in any data source and under our authorization umbrella, and you could enable it using the data connector agent. In conclusion, what I want to highlight is that when you set up policies or permissions and then you enforce those permissions, the whole idea of setting it up in Hasura is very intuitive. And as we saw from the performance benchmarking that we did earlier, it's highly performant. And this whole authorization model is generalizable over any data source and not restricted to a certain flavor or certain database system. And this whole system is getting better every day. That's all from my side.
Akash, that was awesome. Thank you so much. Really nice to see, Postgres, which of course has been bread and butter for a long time for Hasura, making such improvements, and then us, in relation to it. That's awesome. So thank you so much, Akash.
Yeah, thank you. Thank you for the opportunity, Rob. Bye.
Yeah. The point that I was making there is that Postgres has been obviously part of Hasura from the very beginning, and what we're going to shift gears to next is going to be, the future of what's coming up with Hasura, which is V3. We've had both of these folks on a few times recently. Let me go ahead and bring Rahul up on stage, and then let me find Martin in my list here. I'm going to turn it over to you folks because you are experts in all things V3, and I am just here to smile and wave.
So Martin and I have some DX updates and prototypes to share with you. Before we go into that, I want to kind of take a step back and remind everyone of Hasura's promise. And that promise is going to become even better and bolder in V3, which is you bring any data source of your choice and you get the fastest, cost-effective, most secure, reliable API in the world. Now, the question is, how are we enabling that promise? And two open source projects, two open source innovations in V3 are the bedrock of fulfilling that promise. The first one being OpenDD specification for API standardization and data modeling. And the second one is native data connector specification for building rich integrations with data sources. Now, what does OpenDD spec let us do? It helps make the server declarative so that we separate build and runtime, and we ensure that the SLAs are very strict SLAs are maintained all the time. Secondly, it helps in a code-first approach because all you need to think about are models, commands, relationships, and permissions, and you should be able to encapsulate any business logic using the Hasura API. What native data connector specification gives you? It gives you native data source specific features such as pagination, push down authorization, which we saw in the previous presentation. And it also provides a useful data abstraction layer. And the main purpose for that is to scale connector development to Tanmay's presentation, where we are releasing the connector SDK, and also allow community members like you to build any data source of your choice. So what this results in is this layering of authoring, metadata authoring, which you see here from the database to the native data connector to V3 engine and to the client. So there are different specifications and schema in that authoring flow. Now, so there are trade-offs here. The trade-off is that, yes, the concrete specifications help, but what they end up doing is provide multiple metadata objects to think about, multiple concepts to think about. There are multiple authoring layers. And the declarative approach helps in providing the server SLAs, but it also basically means that we need to write more lines of code. So how do we balance these trade-offs? We need strict SLAs on the cloud, but we also want to do things faster and do things easily. And that is where today's presentation, at least my presentation, would be around language server protocol. And what does a language server protocol do? It helps you autocomplete, it gives you code actions, it gives you a quick way to find all references in your code. And it also provides flexibility and control. You can bring any text editor of your choice, and you can also organize metadata in any directory or folder structure you may feel like. So what I will show right now is kind of a VS Code LSP proof of concept. I will do 3 actions. Connect native data connector. I'll fetch the schema for the native data connector, and I will track table within VS Code. You can sign up for beta for Hasura V3 using that link. And we would love to know what features, code actions, workflows would you like on the LSP. And we see a future where you could do many fancy things using just a text editor. So with that, let me show you a brief demo. So the journey starts with the Hasura CLI, where I will create a local project. So my local project is created using Hasura local init command, and I get a blank metadata YAML file. And this is where we get into the whole authoring experience and using the LSP to help us author metadata in a fast manner. So let's look at, this is VS Code, that YAML file that just got generated. And let me see what commands are available. So this is what the LSP is enabling. It is enabling Hasura specific commands within VS Code. The first step for me is I will add an NDC data source. All I need to give right now is a URL, and I'll be using Postgres behind the scenes. So let me bring that URL here and name this data source. And that's it. I need to just input these 2 things, and I'm ready to go with the next part of the workflow, which is fetch schema. And this is the one-click experience and low-code experience we want to provide, even though you are working with metadata files and code-first approach. So if I fetch NDC schema, my schema gets populated on its own, irrespective of whether it is 35 lines or 45 lines, it doesn't matter. Whatever declarative, explicit metadata is required to run the server, the code action will provide you with that. I have one table here. This is all a prototype. Let me add more tables going forward. We just had these tables today to have, but let's say, so I added more tables here. And the next step for me to track table, because that's a favorite feature in Hasura V2, isn't it? So we go and do track table, and there you have. I'm able to track tables through a code action. So let me track album. And what it does, it helps populate all the OpenDD metadata types by itself, where you don't have to type anything. You are basically all ready to go. All you have to go do right now is go to the CLI, build the metadata, and start testing your GraphQL. So we would love to know, do you think this is going to be intuitive for you to work with? What other code actions and workflows you would like? But this is something we're going to invest further in. And please sign up for beta in August for V3. And with that, I'll hand it over to Martin to show or should I move on to the next slide or give it to you?
Yeah, you can actually just toss it to the next slide, and I'll take over right after that. So, yeah, so going forward, we also like following on with that demo, we still have like a commitment to, while we're bringing code to become a first-class citizen within Hasura, we also want to still have that same like prototyping, like UI environment where you're able to, really action on your metadata using like an interface of sorts, and like have that as part of your user experience for when you're developing. So I got a bunch of questions that I'd love if people just like throw in the chats, but like we have the quantitative data around how people like to use the Hasura console, but like what are your favorite console workflows that might be non-apparent to us? Just from the data, like, is there anything in the console that you do on your day-to-day basis, which is kind of like non-apparent? Are there any like hacks that you do? Those are the things that we really try to, capitalize on in terms of like improving our experience. And we're going to show a demo in a couple minutes for that. We're really trying to create an experience where inconsistencies and breaking changes can be gracefully resolved. So for instance, I love that. The permissions copy and pasting, that's a big one. So we're not going to talk about that today, but that's a really good one in the chat. Resolving inconsistencies and breaking changes, we really want to create an experience where you can be allowed to have gracefully inconsistent metadata and then come back and fix those elements later. So if there's anything around there at all that you run into as like a real blocker in your workflow, we'd love to know about it, because it's really something that we're looking to change and improve on in the new V3 architecture that we're working on. Coding in console. So we're about to show something which is a little bit more visual. So Rahul had an incredible demo, which is just showing like, how you're actually able to work in like a really high fidelity code editor environment, probably the best code editor environment you can use. What we're going to show is something which is a little bit more on the visual side, the hot tasks, like the golden paths, and then like the tooling that you can do from a GUI. But you'll notice that like a difference from previous community calls to this is like we have a little bit lower, like less of like a text editor experience in there. So that's something we'd love some feedback on. If we're going in the right direction, we're sort of prototyping multiple streams as we go, kind of thing. So we'd love your feedback on that in terms of like how you're looking to work with Hasura, especially from a console, from a UI perspective. And then, we have this kind of console and code. Everybody's a first-class citizen now. You can sort of work on either side, and there's gonna be a lot of collaboration between like, within teams and such. So, we're not going to touch on that too much today, but that's something that I'd also love to, get your feedback on in the, as we're doing the demo. If anyone wants to send us an email or throw up any like thing in the chat, I'd love to talk through it a little bit. Beautiful. Sounds great. So yeah, this is our new console experience. We've shown a lot of this kind of stuff before, but I think some of the main things that I wanted to call out is, as we're like, trying to envision this editor, which is a little bit more graphical, having this idea of having like the documentation as a first-class citizen is also something like, if you've used the Hasura console, you'll know the little, the little question mark tooltip. So that's something that we want to definitely make like, right up in center, very similar to GraphQL, how you use it. And we're going to be improving that as we actually write all the docs and make the experience more effective. So if I make like a small edit to the metadata here, one of the things that I'm trying to show off is really how fast everything is. So like in terms of like what Rahul was showing, we're doing a lot less round trips to the database. Like we don't want to be hitting the database for like every save anymore. We don't want to be checking at runtime the consistency of metadata. We want to sort of have everything cached so we're able to do that. And when you need to talk to your database, make that a very explicit action you're going to do, where you're we're not doing as many round trips anymore. So we're able to create builds and metadata and artifacts more quickly. Let's say I track a model here. This is again showing like some of the workflows. This is like very similar to how you would do it in the VS Code demo that we just saw, but there's going to be a bunch of like sort of tooling and golden happy paths that you can use and utilities that you can get from the console, which will allow you to prototype and work faster, and then move back and forth between those two modes of editing things. So for instance, I could import multiple tables from my Postgres database as models over here. I can also just from my quick sidebar here have these like models that are importable. So let's say import artist. We really like Chinook, so album and artist here. So again, like everything's been sort of pulled offline. So we almost instantly, without having to hit the database, have that idea of like suggested relationships, for instance. So if I go over here, I'll close up types and interfaces because we don't need those right now. And let's say I go to models. one of the things that we're trying to do is, so I just imported this, so there's no request to it. But one of the things that we're trying to prototype right now is this idea of safety. So you may have seen a schema registry, which is currently a cloud feature, but that's something that we're looking to bring to console as well, which is this visualization of whether or not it's safe or not for me to edit this model. So for instance, if I've got a schema and it's being used by a lot of clients and there's a lot of requests coming to it, we don't want to make changes to it. So from that side, we really want to bring that into the console as a first-class visualization experience, because it's something that can save a lot of people a lot of heartache when you're working with models and stuff like that. And we're going to have a lot of different strategies for how in V3, because everything's so explicit, what we're able to do is have models which are like based off like the same data source. So you're able to have like, deprecate models as you need to. And we're going to have a lot of like, evolving model type of recipes and movements through that. So let's track some of these relationships. One of the other things that we really want to do, and this is a pretty early example, is and it's not 100% still buggy, but we want to have like a lot more visual indicators. So be able to like show connections, like show how your graph is building out over time. So this is like a really easy example of like, you've got two tables and they're connected to each other, but we're going to be doing that at a larger scale where you're going to be able to like select different things and like, see how they're connected within your graph. So that's again, one of the things from the console side that we're looking to be is like, like around things like permissions and such as well. When we're trying to look at like, how are we going to visualize this? We have a whole new take on how we're able to take a look at the data and how we're able to like, craft your API. So we're going to like, use this as an opportunity to explore some of those types of elements. So let's say we have our relationship done. Yeah, the last part is like, and we may have seen this earlier, but like we are like upgrading our GraphQL to be in like the newest version of GraphQL so that it's a lot more, it's just nicer. We also have like a customized version that we're putting together, which will have the headers and stuff as like, hotkeys very similar to how we have in V2 right now. But yeah, like that can again give you that example of like, doing querying across both of these with the joins. So you've got albums, artists, albums, and we're able to see both of those across the two different sets of data that we've queried. So there's a lot of very cool stuff coming in V3. We're really excited to see how the console will evolve with that as well, to be able to like, take advantage of a lot of these new patterns that we're putting together. So yeah, happy to answer any questions about the UI side in the chat. Feel free to drop anything you like. Thank you, everyone.
Thank you.
Thanks to both of you folks. That was awesome. Every time I see, especially a console for V3, I get really, really excited. As much as I love seeing code becoming a first-class citizen, I'm just a sucker for a good interface, and what Martin showed looks really great to me. Next up, we're going to talk about aggregation queries around computed fields, and we're going to have Tom join me on stage.
So, recently, my team, the native databases team, has been working on a feature called logical models. And some of you may know it. It's out in the wild now. And the short story is, to implement it, we basically had to refactor and rework almost every part of the pipeline of a request. And along that way, we bumped into a couple things that have been long-standing user requests and thought, well, we're here. Why don't we fix them? And so one of these things was what I'm going to talk about today. So assuming everyone's kind of basically comfortable with how Hasura and GraphQL works, we can set up queries that look like this, where I have some authors, A author, B author, C author, and they have some articles, and we can make these sorts of queries, nothing too scary going on. Hasura has a feature called aggregation queries, which lets me ask questions about aggregates of information. So for example, I could say here, if the live coding gods are being kind today, I could say, tell me how many articles each author has written, right? So author has written 2, B author has written 1, C author has written 0. And this is great. So I can do some basic aggregation. It's particularly useful if you're doing sort of client-side UI development. These are just helpful things to be able to do within the same query. At some point, though, you realize that you're kind of limited to only being able to talk about fields within the database. And actually, it's helpful to talk about results of functions on that data. And so for this, Hasura has this feature called computed fields. The idea is we can take a function like this, which says given an article row, I can compute its word count. How do I do that? I split it by spaces and then see how many pieces I get. And that tells me the word count. So by adding that as a computed field, I can make this a little more interesting. And I can say, give me the word count of all the articles that each person has written. Great. So we have aggregation queries, which let us count rows, sum them, average them, what have you. And we have computed fields, which let you calculate values based on the data in that row. And it's a bit weird that we've never been able to aggregate the results of computed fields, but now we can. So we can ask very simple questions like, for example, for every author, tell me what the average word count is of all their articles. So this is an example of a function that is running on every row, and then we aggregate the results of those computations into some output value. So this works for both comparable and numeric fields, which means you have max, min, sum, average, standard deviation, whatever you like. We've done the whole set. And this, at the moment, works in Postgres. We do have plans to implement it in other backends, but anything Postgres or Postgres-like, so Citus, Cockroach, etc., this should be good to go. And this is out already. As you can see, this is on cloud. So yeah, try it out. If you have any questions, let me know.
Tom, that was awesome. That was my first time seeing it, and I'm very excited about it as a front-end engineer with my own projects. I can't wait to use that. So thank you so much.
Absolutely.
All right. All right, I'm going to save the trouble of putting my slide back up here, but I'm going to go ahead and bring David Malini on stage, who's going to talk to us about group by advanced aggregations. David, how are you?
I'm good, Rob. Thank you.
Yeah, no worries.
Let me share my screen and we'll jump right into it. I'm sure we're tight on time as usual with all the cool stuff we're presenting today. Yeah, so let me jump into it. So today what I'm going to be talking about is an RFC that we have open for adding a group by feature to our auto-generated GraphQL. I'm sure most people on the call are familiar with how group by works in SQL, how you can group similar columns values over rows and kind of come up with aggregations. And this, we're focusing on this feature because of client demand. There's multiple requests out for this, and there's been a lot of reactions, and it covers a tremendous number of use cases. Previously, like just to cover what is changing, people have addressed these kind of workflows by creating views, functions, or native queries. But this requires users either get access to the database, to create the view, and it keeps a lot of the stuff in GraphQL coupled to what's in the database, rather than being this kind of semantic layer that allows developers to rapidly develop using Hasura. So going forward, after we introduce the group by feature, it'll be natively supported in auto-generated GraphQL, and users will be able to take advantage of it. Yeah, and this really just adds to our value proposition. You get more flexibility and control, being able to put the control in the app developer's hands rather than having to wait for something to be created in the database, and you don't have any kind of mixed dependencies. And then all the SQL generated by Hasura, that it's very performant. You don't need to worry about like badly written SQL or SQL that could be potentially optimized. And then scalability and maintainability. I think everyone here has experienced a ton of views and stuff being created in a database, and as like more people use it, more use cases get leveraged, it becomes a mess. And I already mentioned like analytics and reporting, similar to what Tom was just focusing on. It unlocks those kind of use cases and a lot of kind of analytics use cases that you might have. Here's just an example of what a group by query would look like. We talked about the Chinook dataset earlier. This is based on the Chinook dataset as well. And here we're going to be grouping by billing country, and then aggregating on the number of invoices per billing country, and then as well as adding invoice ID and customer ID nodes. So you can see here, this is the resulting response or truncated version of the response, and you can see the billing country, the number of invoices, and then the nodes as well. This is an example of the SQL that's generated. This is not a verbatim example. You can see more detail regarding all the different kind of features to be considered within Group by in GraphQL. This is kind of the verbose list. It's all inside the RFC. And we would like to welcome just everyone in the community to take a look, give us your feedback. These links will be added to the chat if they haven't been already. And there's also, if you're interested in getting early access or updates regarding this feature, please fill out this form. On the form, there's a question regarding which database you'd like to see the group by feature added to first. So please fill that out. It helps us kind of prioritize based on user interest. We'll be adding this for all databases. It's just a matter of which databases we'd like to add group by to first. Yeah, and thank you very much. Sorry to breeze through that pretty quickly, but I know we still have a lot to present today.
David, thanks so much for being efficient with the time and for all the information. That was great.
Yeah.
All right, we've got 2 more demos coming up from folks inside of Hasura, and then we have a community demo that's coming up after that. If you'd seen the agenda earlier, we had a few updates that were going to be coming through. They're just kind of short things. I'm going to throw those towards the end of the call itself. But next up, I'm going to bring Naveen on stage. Naveen is going to talk to us about input validations for mutations in the console.
Hey folks, this is going to be a pretty quick overview of how we'll be using input validations. And to give a very brief overview of what input validations are, they're nothing but it's a feature which helps you to validate mutation arguments before you actually insert, update, or delete them from your table, right? And let's take a pretty quick example and say Hasura is powering your blog app, and a pretty common use case of a blog app would be to able to insert author with their articles, right? And the sample mutation might look something like this, where you insert an author with their name, email, and their author articles. But the problem here is there's no help where you could validate your email or validate your title, right? So if I just go and press the, oh, sorry, looks like my improvisation already present. 1 second, sorry for that. Okay, sorry, yep. So if I, assuming there's no input validations, if I just go and click enter, then you can see that this email with the bad email ID is entered and has been set into data. Now, if you don't want this to happen, what we can do is we go to a permission tab, click on the permission for each of our tables, and then go to insert permission, click on input validation, enable them, and just have a hook. So my hook is something here. So I added a article validation hook, which is nothing but a pretty naive implementation written in Python, which just doesn't allow any special characters in the title field. And for the author table, let's do the same thing. We would like to validate the email of author. So let's go here, click on the user, then click on input validation, just enable it, and let's add a hook here for the author and just save it. So this hook again does a rejects match, which we shouldn't be doing, but yeah. So it does a rejects match to confirm if the email is a valid email or not. So let's go back to our console, and now with the permissions enabled, which has the input validations and a role has been set as blog user, let's try to insert it. Ta-da! When it doesn't, the validation hook doesn't allow you to insert it because it states that your author email ID is not valid. Now let's try to fix this up so that we can trouble drop with the proper email ID. Then we try to insert it. Now let's see what happens. Oh, we got another validation hook because the article validation hook caught the condition that we didn't want any special characters in our title. So I'm just going to fix it up, and I'm gonna run this thing, and which successfully inserts it. So this was a pretty brief overview of how you can enable input validations and what advantages that it gives to you. And that's it.
Do you want to give us a little bit of an intro as to what you're going to be sharing with us today, and then I'll get out of the way and let you demo?
Yeah, absolutely.
Okay.
So we're going to talk about monetizing Hasura GraphQL APIs for fun and profit. And I'll just go ahead and jump right in. Yeah, so I'm Dawson. You're a friendly neighborhood platform engineer, DevOps engineer, SRE, whatever you want to call it. Also a part-time digital nomad. I like to hop around the country for the last year and a half. And as I travel, I like to try out the local bouldering gyms. Jumping into our problem set, I was working with a company, Parcel Labs. They are a real estate data startup seeking to provide real-time distribution of residential real estate data, how much something sold for, when it sold for, and they're trying to provide that rapidly. Hasura was chosen because it enabled them to provide a rapid deployment and product that was a kind of a modern API that fit their needs. However, they still need a way to track and bill usage. And stepping back for a second, as far as usage goes, typically is done by metering your API. It's the foundation of being able to monetize your API. How much value were you able to provide from a given request? How are you tracking this? Very common for REST APIs to do this by request count. However, with GraphQL, you're kind of able to pull the data that you want and need. So it's not necessarily that all requests are equal in that sense. So we kind of want a way to give that true SaaS, pay for what you use spirit there. This also allows you to align cost with your operations. So are you able to track how much data you're able to give, end user? This is particularly helpful for real estate data where you might only care about a given area, and you can kind of hone in on the details and area that you require information for. And this is kind of where Hasura was able to lend a hand. Again, they have a HTTP log, which contains a subset of information about the request itself, including the response size, how much data did we send back to the client. And we'll dive more into this in just a second here. But by leveraging Hasura's webhook auth mode, we can kind of provide a layer of governance for this external GraphQL API that we're providing customers. Like, are they authenticated? And do they have the permission to reach this endpoint? And also, more importantly, have they reached their allotted quota? Have they already pulled 5 gigs, this week or this month or whatever the billing period may be? Here's a quick overview of what this governance gateway that we can kind of put together and put in front of this webhook auth mode. You can see on the left, we have your valuable data wired up to Hasura, as well as load balancer and your end user and app. By passing forward these auth headers to the webhook auth service, we can first initiate an auth flow and then perform a user lookup on their usage. And again, we will take a quick look at what such a service might, how it might operate. So I put together a quick demo. In this Docker Compose file, we have a logging service, just Fluent Bit. We use this configuration to extract the HTTP logs, kick it out to the containers SDB out for debugging purposes, and also kick it into what will be our ingest service. Now, typically, I'd recommend ingesting logs through something a little bit more durable like Kafka, but for now, we'll just keep it confined to our small app here. Running back over here, we have Postgres, which is, again, our valuable data store fronted by Hasura GraphQL engine. You can see down here, we actually configure the logging driver as FluentD, and we point it towards the container running Fluent Bit. One thing to note, we do have this magic IP, both mentioned in Fluent Bit config and the auth hook. Here, this is actually just part of Lima. It's running Linux on Mac, and this is the loopback address for my computer. We're not actually running the app in the container, so we'll go ahead and start that real quick. We'll see it fire up in development mode, and then we'll go ahead and fire up Hasura, the log collector, and the database. So let's switch back over here. We'll give this a quick refresh. Just to enter the correct password here. We've already preloaded this with a valid token, and we'll briefly cover over the code real quick. As you can see, getting customer with the admin secret, we pull a bunch of data, but what we're more interested in is what it looks like when we're able to pull data with a separate user. Switch back to 1 real quick. And I have made a slight error here. Fire that back up to 0 those out. Our demo doesn't account for the page that gets loaded, so it actually adds to the quota we've set. Briefly covering what this looks like here, we have a user 1001, 1002. They have a usage that gets zeroed. There's a global quota right now for 2,000 bytes, and then we have a quick token dig on which exactly user is being mapped to their token. And this would all be handled by an auth service or a separate set of services, but we've kind of wrapped a gateway and a ingest service into one little app here. The webhook auth pulls the authorization headers. We set the user ID by looking the user up and through the authenticate function, which literally just checks that dictionary there. And then we check the quota, which we provided in memory via that usage map. If it's all good, we send back a 200 to Hasura, and Hasura says great, and I'll receive the request. Otherwise, as you saw earlier, we exceeded the usage, and the user had to get a message that basically said they weren't allowed to do it. Now, since we restarted the service, we should see this function, and we will see down here we've recorded 725 bytes for user 1001. We'll click this once more, and now we should be at 2175. Given that our quota for the global quota service is 2100, we will see the next request fail. There we go, authentication hook unauthorized for this request. So we've effectively metered their usage. We're able to track it, and then also, prevent them from necessarily making more requests until their usage has been bumped. Yeah, and then this is just the parsing of the Hasura HTTP log. Again, probably not the best idea to roll it into one app, but for the purpose of this demo, it works really well. Yeah, that's about it. Built a out-of-box solution that kind of helps API metering and governance with Hasura deployments. If you want to hear more about it, reach out. Thank you.
Austin, that was awesome. It's always great to see what folks in the community are building with Hasura, and very neat implementation. Thank you so much. And we'll wrap things up for today. We have just a few more small updates for you. Let me advance a little bit here. We have a few short updates for everybody. First off, probably most of you are familiar with the idea of restified endpoints, and if you've used this in the past, the workflow has been to start in GraphQL in the console, go ahead and write your query mutation, hit the rest button, and then configure the endpoint itself. But we now have the ability that from a table within the data page of the console, you can actually create restified endpoints with one click. So we highly encourage you to check that out. We should have some information about the docs for that inside of the resources that are here. And then, of course, if you just go to your database tables inside of the console, you'll find that there's some very cool stuff. Schema registry, if you are a fan of having your notifications come via Slack instead of through email, we have now configured Slack alerts, so you can choose a dedicated channel for schema registry updates to come through. Again, that information is in the docs as well, so you can find all that there. If anybody's been using the Open API import for actions, we now have support for the 3.1 spec as well. And apparently I left Tiru's name in there, so he gets a shout out as well. Additionally, we have some progress that's been made on SQL Server stored procedures and Azure being available as well as a deployment option. So again, check out all that information in the docs. If you are a fan of OpenTelemetry for exporting metrics as well as traces, we now support metrics being exported. That, I believe, is in Cloud Enterprise and then the self-hosted enterprise options. So check that out if you're looking for ways of configuring those exports and being able to diagnose things like bottlenecks and whatever may be happening with your instances. And then finally, if you are an enterprise user, we have a lot of new guides and information up about SSO for the console. So if you were to go into the enterprise directory inside of Docs, you would find some information in there about how to set things up like Dex, Azure AD, Google, lots of choices and lots of direction there. And of course, if you have things that you would recommend for us, let us know. We're always looking for that feedback. That was Dawson's slide. A few community updates just to kind of cap things off for the day. We've been paying attention to a lot of the different issues that we have on GraphQL Engine and those that have made a lot of progress recently. Hopefully this one at the top is making a lot of people excited that we now have native support for Postgres arrays. So please do check that out. Additionally, this second one, if you're somebody that's bringing in really large tables or schemas, you may have encountered maybe not the most efficient process and it took a long time, but now it is lightning fast how those tables can become tracked. So please do check that out. And then finally, we've resolved an issue with header resolution for environment variables in actions. So again, those are just some open source issues that have popped up. We have some upcoming events as well. You'll see that first we have Google Cloud Next happening at the end of August in San Francisco. Of course, it's a very large event that we're involved with. We have GraphQL Conf coming up too in September, again in San Francisco. And then of course, if you didn't make it to HasuraCon or if you just want to sit there and rewatch everything again, we have all the information from HasuraCon 2023 at that bottom link as well. Finally, we're always looking for feedback. So if there's anything that you folks would like to let us know, these are the channels that you can reach out to and give us an idea of how we can help you. And thanks for your attention today. Thanks for your patience as we went a little bit over, and we will see you folks next time. Thanks so much.